Hello and welcome. I'm Bill Wake. We're here working on episode 2104, so the fourth episode of an Elm interpreter. We've already been working on integers. We basically have those working to at least version 1, and we're working on floating point numbers now. So along the way, we're going to learn about Elm, Swift, parser combinators, and probably other things as we go. We've done a little bit so far. We'll do more. All right, so we've done a few combinators, match, mini one, combine, and we've done part of floats along with integers. We're going to finish floats hopefully today, and that's going to require some more combinators. We may go, if we go further, we'll probably either deal with the character view issue versus string, and maybe get into spaces and possibly the REPL read eval print loop. And further on down, maybe later this week, operators. Okay, I'm not quite sure what to tackle next. I think I think the issue of space is maybe just to kind of get past that. But we have our hands full already. Let's see. Um, Let me go in here. Okay, so we're in Xcode. We're writing the interpreter in Swift. I'm not going to worry about JavaScript. Elm historically has relied on JavaScript and compiled to JavaScript and so on. I'm playing around with a different thing, and it is Let's Play style because I don't know what I'm doing in detail anyway. I used to work at a on compilers at Digital back in the day when it was Deck still and still a company. Um, so I've got some background with doing this and working with grammars and so on, but the details here, I'm playing it straight with you. I'm doing what I'm doing. So that means you get to watch me flail around. So I'm always happy to have comments and feedback and ideas because I really don't know everything. That's going to become very apparent. All right, so where we left off, let's see. Let me find, I think, orient ourselves with the grammar a little bit. So let me open this in Finder. Oh, it's so slow opening in here. Okay. Oh, I had Keynote up. I probably should have just used that to find it. Maybe that's still faster. Elm grammar. Okay, so what we've done so far is an integer literal goes to digits plus. Plus means one or more. It's metasyntactic, it's about the syntax. And we've started floats, but floats have a digit followed by dot, followed by one or more digits, followed by dot, followed by one or more digits. And then you have this optional stuff on the end. It's all in question marks. This is sort of, if you're familiar with regular expressions, this right now is still a regular expression. As we develop the grammar, it's going to be more of a, well, it's going to be more of a type 2. It's going to have stacks, context-free grammar kind of thing. Um, okay, so we'll tackle those after we tackle this, but right now we can do digit plus, but we can't do digit plus followed by this followed by that. So that's where we left off. Let's see, get myself cleaned up here. Save that. Back over here. We've got float tests. We have one test, and I put an X in front of it because it doesn't run. Okay. It would says what it's trying to do is say I've got a float literal parser, and I feed in a string 42.1x. What I should do is pull out the 42.1 and leave the x for the next parser that comes along. And once I get it back, I should see the number 42.1 to some accuracy and an Elm type of float. If I don't, that's an error. And I should see X for the rest of the string. So this AST is abstract syntax tree, meaning the tree we're building that we're going to interpret from. It's sort of the intermediate form, I guess you could say. And the rest is the rest of the input. So we can pull out pieces of the tree and then feed the rest and let the next parser take on the rest. Okay, and then where we left off, our failing test is test then. So I guess I'll make one more connection here. Where's float? Not an inner Elm parser. Yeah. So we're saying a literal integer literal is character digit, many of these combined to form a Elm integer intermediate type. Over here, we're saying this is a floating point literal is a then, which I think we'll rename to sequence, but it's first the many digits followed by a period only, followed by many digits again. And each one of these is a little miniature parser. And that's the thing about combinators. A combinator is a basically it's operators that take parsers and produce other parsers. So given a parser that can match one digit and a combinator that says, I know how to match many or more of the parser you give me, then this forms the this combinator can do the job of making a digit parser. And then we add another combinator that says, give me that parser and I'll turn those characters into an Elm integer, which is our intermediate type. Let's go to AST. So Elm integer is a value that's an integer and it's a type that's going to be number. There's some complications in Elm's interpretation of what the types of numbers are, and I don't know why. For a language being strongly typed so many ways, it's funny to me that there's such ambiguity there. Like right, here we are, two types in, and we're dealing with it. But that's what it is. Okay, it does have an integer type as well as float and number, and it's got these kind of automatic conversions to let the types go between them. I don't know the details, but we'll be learning them. All right, so float tests, and the reason this got commented out is because this then thing that we saw a minute ago doesn't exist or doesn't do anything. That's parser tests. So we can test match. It calls a function and makes sure things are good. We can test that it rejects and so on, but we haven't tested anything about sequences. So we left this here to force ourselves to implement some tests for then. Okay, and so we're going to make a parser, and a then takes an array of parsers, or actually a dot dot dot, I think. Let's see if we can get there. Yeah, it takes dot dot dot. So it's I don't know. I learned to call it var args. I don't know what they call it. Variable number of arguments, but it puts it in an array for us so we can work with it. Okay, but we got to give it two parsers to work. So let's just give it two easy matches. Okay. Let's just get a 2-digit number. So, whoops. I haven't tried this. Equals match such that character is digit. Okay. And we're not calling it, we're passing in such that takes a function. The function is the isDigit function, which we added to character. They used to have it, but they took it out because of Unicode, basically. All right, so if I'm going to assume I can call this twice. I don't think it's carrying anything. It's a parser sitting out there, so I don't think it has any state directly. Okay, so now we have a parser. We're going to parse with it. Let's we'll say array and rest equals parser dot parse of 12 z, or what would be good, 12 dot. I'm trying to pick different data each time just to kind of test the range of values. I don't know. I'm doing a lot of thinking lately about how do I choose my examples, and maybe this example is more than we want. So if I think in terms of 0, 1, many, I'm not really doing that here. Maybe it would be better to start with 0. And let's do that. Hmm. I don't know. If it's not too hard to do multiple ones, then we should just do the multiple ones. But I do think I'm kind of not sure how I want to go here. So let me simplify things. And let's say for no parsers returns empty array, I guess. Okay, so if we go to then, it's going to return a parser that returns an array of something. Okay, and we don't have to care what it is for our purposes here. I don't think we may have to put something dummy in there or something. I don't know. We'll see. Okay, so A could not be inferred. Interesting. Well, let's start with 1 then. I was assuming you could have an empty array. Huh. Okay. Returns its result. Okay, well, we'll do it this way then. Okay, so this is digit equals match digit, and we're going to say then digit. Okay, so this is a sequence of 1. Okay, and immutable array. Oh yeah. Okay, well, let me get to it. All right. Okay, so that's all set up. Let's kind of make arrange act assert, right? So this is setting something up. Here's the action, this parse, and then the result I expect. Well, I expect a character. No, it's an array. I expect one digit. Interesting. I think I will get an array with 1 digit in it. Okay, then produces an array, and then the result is array. Okay, or the thing I'm testing. Yeah, I don't think we care. Well, let's assert on it anyway. And if we peel off the 1, we expect 2 dot to be rest. Okay. So I do want to, I'm saying, well, I will verify that this parser doesn't consume too much. It just looks at the 1 digit. Okay. I think this will fail. I don't think there's any way it could not fail. Although I've learned to be surprised now and then. Okay. 1 is not equal to empty array. 2 dot is not equal to empty string. Okay, I think we have it hard coded. Okay. Let's see. It takes these parsers. Well, I think we've done something like that with mini, right? We peel off. That's what we call parse. Let's see. Let's get a result. Parse result is I guess this is parsers sub. Well, let's go with 0 for now. The first one is parser sub 0, and let's see, we got a parse. We're gonna save. Yeah, I guess we're just gonna append the value. Well, we'll do this kind of thing. It could return a nil, and we'll get to that one. All right, but for now, let's just grab it. Okay, so this is my 1 case. Oh my, are you? I really don't know what these mean yet. Okay, so I guess value. What is your problem? So parse result, oh, dot parse. I think we pass in, well, let's pass in rest. And let's make rest equals input. Okay. You're still not happy. Oh, there we go. Okay. So I'm gonna sort of seed the loop here. What are you gonna parse? Well, the first thing is gonna parse the whole input that we're given. Okay, so parse, these parsers produce an array of this, which is the result of each parser doing its own thing. So we'll start with this parser 0.parse rest, and we get a value, and let's return rest 2 here. Okay, so rest 2 is the result of the first parser. We're going to append whatever it finds when it parses to the list so far, and then return the result. All right. My intent is this passes. Like, it should. Yay. Okay. Yeah, I got some warnings. Let me deal with this name first. I don't like then. Originally, I thought I could make an operator of it, and maybe I can eventually, but it was, you know, if it was an operator, it was going to read like parser 1 dot then dot parser 2 dot then dot parser 3. I don't know in a way to make the operators kind of collapse that into one expression. So, and I don't think I want to go down the path of, oh, it could be a single type or an array, and an array combined with an array, or an array combined with a single, you know, this explosion of cases. So instead, I'm going to make this sequence, I think. I don't know. There's a part of me that wants to call it seek. I don't see rename. Let's jump to definition then. Okay. And you have a rename? Yes. Okay. Yeah, part of me wants to just say seek, and alt for alternation, and opt for optional, but I will spell it out, and we'll get there. We're trying to trade off, you know, the grammar is pretty cryptic if you've never seen them before. This, you know, it's like I like a light syntax to it, but you know, again, if you haven't seen it before, it's kind of hard to read it. All right, but now we're saying sequence of digit, and you can imagine we can put more than one thing in there. But let's, let's commit it. It's green. Start making sequence combinator work. Okay, and I can say it was then. All right. And you know, I didn't double check. I think I may have booted my system. Yeah, I have this cat light running, but I haven't brought up the server, Jenkins server yet. So we're running it on our own. We'll keep doing that. Let me run all tests just to make sure. Okay, so surprisingly to me, 0 did not work. Let me see if it can work. Maybe I forgot the parse and it just threw it off enough. Because it would be nice if doing none would make an acceptable empty thing. Okay, let's rename this to sequence. For no parsers, returns, I think it's empty array. It's kind of where we started. Okay, so take this out, take this out. And if it doesn't compile, well, yeah, could not infer. Right. So even if it were returning an empty array, it would be okay, but it's not going to be that way. All right. Let's take another case. Okay. So I think the big combination we have is when you run this parser like match for digit, you either get back one of two things. You either get back the pair of the thing you parsed and the rest of the input that it didn't need to parse it, or you get a nil, meaning I couldn't do it. Okay, and so we have two dimensions going on for our testing. One is, do you return nil if you should, and the other is, do you handle 0, 1, or many sequences? Actually, one or many, I guess. Okay, so let's take the error case first. And so if we have a sequence of digits, but our input is dot 7, okay? We want a digit, we're requiring it. We don't see it because we see a dot. And I think this is, let's just call it result. And let's take this off because it's going to be a nil. Okay, so let's assert nil result. And there is no rest. Okay, so if you fail, you just return a nil. I don't know what they do in production kind of parsers for these syntax errors. The definitions I found on these combinators, they just kind of take this lazy way out. It may be that we need a more sophisticated result type that, I mean, like somebody could say, I was looking for a digit, I didn't see one. Okay, that would be an interesting, at least moderately helpful message. Or maybe I was looking for either a digit or a plus or a minus and I didn't see one. That would be helpful. Nil, I tried your thing and I couldn't parse it, is really not a production use. You don't even have a place where it fell apart. So anyway, so a sequence, let's see, this is sequence for error parser returns nil. Maybe I should say error. Sequence for parser that fails returns nil. Okay, that's a little better. I don't know. I try and get the nil and the low-level language out of there. I don't even usually use nil that much. I try and design things to not create nils, so it's a little different for me here. For a parser that fails, how about just returns failure? Or maybe it's just sequence fails if its parser fails. Sequence fails if its parser fails. I think that's expressing what's going on. Okay, so we're matching one digit. We try and parse a dot, and we expect a nil back. And I guess we're hoping this fails. I don't think we wrote enough code. We put an exclamation point in there, so I'm pretty sure it's going to. Yep. All right. So parser. So we have parse result. I don't know. We can kind of take this early exit here. If parse result is nil, return nil. Okay, so if you try to parse and it fails, then the sequence fails. And I guess we don't have to worry about result and rest and all that because you're just saying the whole thing failed. My sequence failed. I tried to do a sequence, it blew up somewhere. All right, let's do these tests again. I'll run them all. Okay, and I don't know, I also should say, I'm sure there's going to be easier ways to do this stuff once we get it together more, but I'm being explicit here. Okay, test did pass. All right, so that's good. That gives me hope that anywhere that it fails will be okay. So let's try this. Test sequence for multiple parsers returns array of results. Okay, and we will do this again. Oops. All right, so we're going to match two digits. I don't know. Does it matter? If it works for 2, I don't think it's going to have a problem for more than 2. Okay, we'll do a parser.parse. And we're looking for a success. If I parse it out of 7, 8, 9. Okay. And we'll do an assert. And now I expect to get back 7, 8. And my rest is 9. Oh, whoops. I'm asserting on... Whoops. This should be rest, should be 9. How are we doing? Okay, match 2 digits, parse 7, parse 8, should be getting in the array, and then the rest being 9 should be in there. All right. This will fail. We'll get back 7, but I think our rest will be 8, and we won't see the 8 in the array. Okay. Oh, 8, 9. Yeah, that does make sense. Okay. Feels like it's going a little more smoothly today. It was a little clunky the other day, I think. But anyway. All right. So I guess this is, we got to flip this thing to a loop. And let's pull out this. Will you let me extract a variable? Extract a variable. Let's call it parser. Okay. So it may look like I'm making things worse, but let's hope it gets better. All right. So parser is that. Okay. So I think we want to say for each. Well, I guess we want to say parsers dot for each, and then the body is parser in, and then somewhere this ends, probably before we return. Okay, and this doesn't matter, and let's format. Unexpected non-void return value in a void function. A parser of A, let's go to its definition. Whoops. Parser is a thing with a function that returns a nil. Oh, we got parser of A sub input in. Did we fail this before? Input in, return no. Unexpected non-void return value. Return parser. Oh, am I not balanced out? Cannot find rest 2. Something's funny. Parsers.for each parser we're going to do this. If it's nil, return nil. Well, maybe I'm being misled by not being an extension. What is it more like? I mean, this thing should be returning a parser. Let's take rest2 of string. Oh. Now I do get confused with this. I'm setting this closure. So this way I understand this syntax is I'm creating a parser of arrays of stuff, a parser yielding arrays of stuff. I'm giving it this value, which implicitly assigns it to parse. So I should be defining a function that takes a string and returns an optional a string pair. This is okay. Unexpected non-void return in void function. Maybe my parsers for each is not the way I think it is. Calls the closure on each element in the sequence in the same order as a for end loop. Okay. Using return will exit only from the call to the body, not the outer. Okay. Well, let's do for parser in parsers. Do this. Okay, so rest is never mutated. I guess I got to make rest equal rest2 somewhere. Rest2 used before initialization. Oh, jeez. Okay, we'll start empty. We know it will be set somewhere. Okay, rest2 equals rest. Rest2 is a let constant. I don't know how you do that. I only want one of them to be a. I guess I can make value, same thing. Var value of A. Are you going to get confused? If I do that, rest was never mutated. That's more like it. Okay. Parse result was never mutated. That's probably true. Okay, how are we looking? We got a value and a rest too. We parse rest. I don't know. Am I making this too hard? We parsed with rest. I guess I could just make this rest. Skip this. Skip this. All right, let's run our test and then chat. I think it should pass, but it looked a little sloppy in there. Okay, good-ish. All right, so we create a result. We got to accumulate things into it, so I think that's probably okay. They're a real Swift person would probably be able to school me in doing this better. Okay, but rest is input. I'm going to pull value up above it. Okay, so for each parser, attempt to parse whatever rest is at this point. If you can't, then the whole thing fails. If you can, then we're going to update and grab a new value. We'll pick off the value that you had and the rest of the string after you parsed that and append the value. So we've got it up in here and continue with the rest around the rest of the loop. So the next one picks up where that one left off and then we return it. I know that's not bad. I mean, I'm sure there's a way to fold it together in one big bloop, and we'll get closer over time. In particular, I think at least the versions I've seen with operators, they are able to really fold everything to being in terms of each other. So I don't know how we'll best say this is, but I think there's probably a good way to do it. Maybe the operators are only working in pairs and they kind of simplify it to the single case or something. I'm not sure, but we'll get things working and then improve it as we often do. Okay, so in this case, we have made sequence support one or more items in a row. Okay. And that is good. All right, now I'm happy enough with sequence working. Okay. I'm not too concerned about the error. If it errors somewhere along the way, somebody will detect it. Any parser that tries to run will detect its error, so that's okay. All right, let's go back to float. And let's see our example, 42.1. All right, let's uncomment this. This might even work. I think we've got the sequence stuff, and I think that's all we need so far. Yay, okay. So simple floating point numbers work. Digits.digits. All right, let's made digits.digits. Okay. Now, if we go back, where's my grammar? Okay, so we've done the front half. Whoops. We've done the front half, digit.digitDist. Now, if you look here, the parentheses here matches the one here. So we need something that's optional. And inside there, we have a sequence of two optionals and another set of digits. So we have the operator for a sequence. We have the operator for one or more. We don't have the optional operator. So I think we'll design a case that exposes that. And without the optional operator, or we'll force ourselves to add that optional operator. It's kind of a two-level process because we're working from the grammar through the Elm items, and the Elm items say, I can't be parsed. What do I do? Now we have to build the parser part. So in some ways it would be nice. Well, in production use, probably I would go grab a parser combinator library and just call it and be done. But I'm trying to learn parser combinators, so I'm the parser combinator librarian, I guess. All right, so we'll take a 2-minute break, come back, maybe 3 minutes, but 2 or 3 minutes at most. Come back and tackle the rest of these floating points. I think our first test will quickly reveal we don't have an optional operator, and then we can kind of stack the test and go ahead and work on the optional operator. It should be somewhat like the then, although it introduces this issue of what if it fails. If it gets nothing, it should be okay. So we'll see where that goes. Okay, see you in a couple of minutes. Hey, welcome back. All right, let's tackle these floating point numbers the rest of the way. You know, at some point here, we're going to have everything we need from the parsing side. I mean, we can do right now. We can do digits match according to a function, digits in our case, one or more, sequence, optional. The only thing we don't do that I would call classic is we don't do the ors. And as soon as we try and parse either a integer or a float, we'll do that. And at that point, we've got most of it. There may be something like we want to be able to ignore some things, and like spaces, we're going to try and do spaces and comments at some point. Other than that, I think we may have most of what we need, and then we can refine it as we go. But I think from the client point of view, it's going to be pretty straightforward and simple. All right. Okay, digits. You know, I'm already bored with writing these asserts. Let's pause. We'll just X this out for a moment, and we're gonna parse digits.digits digits. Okay. Um, E, capital E or lowercase e. We're going to leave out the sign, which I guess won't matter. And then digits. Okay. Yeah, so part of what... I don't know if I'm doing this for the benefit of my tests only. But my AST elements... I would really like to just be able to say assert equals integer 3 comma number, and have it match one of the match the thing coming back from the parser. I can't do that because I don't have equals on here. So let's push that in so that we can. Where's my test? Okay. So I would like, maybe we'll just modify this test in place. I'll just call it 2. We'll just borrow this test for a moment. Okay, so what I would really like to do is I would like to be able to say assert equal well, let's see what ast.elm elm float. Oh, capitalize that. ast.elm float 42.1 elm types. Elm types dot float. AST with this accuracy. I can't do accuracy there. Annoying. Float, can I give? Well, let me put it in. 0. Expected target type AST. I don't want to conform AST to floating point, that's for sure. Okay, so maybe this is a bad idea. Doubles may be the only one that deserved that trouble. Huh. Okay, let's go back to E-digits. As we were. Okay. So we're going to parse 42E7. Okay. And we'll put a space after this one. 42.1. Well, let's do E2. Okay, so 42.1, E2, there's E1, E2. I think. 0.1, another 0, 4210. Okay, and that should be good. This should be space. Okay, and this should come back not having parsed the E2 stuff. You succeeded, but you didn't actually run. Thank you. Okay, 4210 is not equal to 42. Blank is not equal to E2 because it didn't parse the E2. All right, now in our parser, wherever that got off to, no, our Elm parser. Okay, a float literal is a sequence of all those things match, but it's also an optional and the optional is a sequence. You can see why people get crazy on these. The sequence is well, I don't have a function for match E. Let's just assume we did. I'd like to have a function that just took a character, or even a set of characters. Let's start here. I can spin up all these things in my head. It could take a set of characters. It could take an array of characters. It could be a double sequence. It could have a qualifier that says ignore case. That might be nice. We'll just get our E in there. Okay, so E, and we can skip the plus minus for now because we don't do anything with it, but we do expect digits to be there. Okay, and that tells me my test really should have two numbers in there. Let's 42.1. Let's do 5. 42.1 5 E2. What did you do? 42.15 42.15.0. Okay. So I match an E. The sequence is match E followed by match with character.isDigit. .many1. All right. Match digits.digits optionally followed by E and more digits. Okay, that seems okay. We don't have optional. We don't have a match that takes one character. It takes a string. Oh, the other one in my head is at some point we have to do things like match case and for and all reserved words. And it would be nice if we just took a string for that. Okay. All right. So I guess the big thing is optional doesn't exist. Parser. And, can I do this like I do mini one? Well, he's actually got to return a parser of many. I don't know with an empty. This is getting painful already. Okay, so what does optional return? It's going to return a parser. This thing all sequence takes a parser, so optional has to return a parser. Well, a parser has to return something. It can't return nothing unless the way we get around that so far is a parser that returns an array could return an empty array. That should be allowed. Okay. So let's make it like sequence. Okay, so we'll make it a freestanding function. It's sequence optional of A. It's got a series of parsers. No, it's got one parser, doesn't it? It's got one parser, and it returns a parser of A's. Because there could be 0 and there could be 1. I don't know how to... well, let's try just A and see if we can make it work like that. That'd be handy if we can. The one I'm thinking of is, what if I pass this thing back? Can I... It's sort of the way void works in Swift. It's kind of an empty record. You know, we have the pairs like value rest. If you put nothing in them, you've got an empty pair, which is sort of equivalent to a void. And so maybe we can get by with that. Let's give it a shot. Okay, and then we're going to return, I don't know. No. Let's just return parser. Okay, so you give us a parser, we give you back a parser. Everything's okay because it's all A land. Okay. Cannot find optional in scope. So if I build it now, I think I've got optional. It should complain about match. Yes. Match character dot many one. Oh dear. So here, the problem, we're getting into that problem I mentioned of sequence. The character is digit returns many. I guess my way around this was this only thing. Okay. So, oh, well, no, this is, okay, I'm going to make myself back up. So the reason we have only is because it converts a single character into an array so it can be used with the other things of a sequence. That tells me that this thing would be actually be handier if it returned an array of stuff in the parser. So if we return parser of array of A, I don't know if this is going to fly. Yeah. Let's return the array parser for now. This is just a dummy result for our failing test. Parser of A to type parser of A. Can I say parser dot only? So that takes, it produces a parser of A given a parser of A. It produces result array of A from an A. Okay. This should be better. Oh, we still don't have a match. Cannot convert parser of array of characters to expected argument type parser of character. Well, let's get match right and make sure. Where's match? Okay. Okay, so I'm going to make this take nothing, and it's a prefix escaping. I want to go from string to bool, and the result is a parser of, whoa, what is it? A parser of array of characters. I think I'm asking for that. And this stuff, return parser. All right, let's get this. Can I just return match? And is it? Even just getting my dummy return values is a challenge enough with all these generics in there. Okay, how are we looking? Elm parser. Let's build. Oh, got 3 brackets deep now. Isn't that great? Cannot convert string to expected argument type string to bool. Cannot convert parser triple character to parser. Well, somewhere, okay, this is a problem. Like somebody's got to do some flattening here. Oh, okay, so our optional is returning an array of 0 or 1. The 1 could be a sequence of match and match. The second match is definitely returning an array of stuff. Oh, golly. Okay, and now here I have this flat map. Oh, that looks like even an extra unused. Yeah. Okay, just to. Okay. Oh. Let's simplify it even further. Let's do match E and comment out this optional stuff. Okay. Cannot convert string to expected type string to bool. Match of E. Where's my parser? Match of. Oh, prefix is a parser. Oh, I don't want that. I just want a string. Okay, so you give me the prefix. I give you back an array of characters that matches it. It'd be tempting to put the string there, but that's not good. Okay, let's see if this is any better. And it may be escaping. I never quite, I guess, not yet. Maybe later. Okay, so that builds. All right, so let's do the sequence. Take the optional out, or leave the optional in, and do this. Okay, so now we're matching a sequence inside to expected type parser of character. So this thing, match E, is returning array of character. This thing is returning array of character. So the sequence is returning an array of character. Now I would like sequence to flatten things if it could, and I don't know if we've so I don't know if it's clear what's going wrong here, but the match here, this thing returns array of character, this returns array of character, this returns array of character, and we combine them with characters to Elm float. That thing did the flat map, but it would be nice if sequence did. But I can't call sequence.flatMap here. And this is, oh boy. See, if I had a sequence, suppose I just had a sequence of A, B, C, that would be it would be an array of character is all I would get out of that. And that would seem okay. If I match 3 letters, A, B, and C, and I get an array of A, B, C back, that seems good because it's all singles. Here I've got arrays. We modified this one to be an array, even though it wasn't. Oh, man. I don't know. This is where I'm not getting something right in my head about this stuff. It definitely shouldn't be, this thing shouldn't have to do this, I guess, is what it comes down to. I would like to just say string of, I would like to give it an array of characters. And I think that's what flatmap is doing, but it's got an array of characters to start with. Yeah, that's the input. This is the only sequence so far, so we're not messing up much else, but it'd be good to get this right now. Boy. And the problem I have is I don't know, in general, this is array of characters. Now this would be a single, but it's an array. This is array of characters. Can I do a flat map here? No. He's a parser. He shouldn't have to do a flat map outside. The stuff out here should read like a grammar. And even this only in the middle on 15 is not, I don't like it. I think it's reasonable to ask that your stuff be homogeneous. So it's compromise-ish, but definitely a sequence. Oh man, I'm not sure what to do here. So I don't think our sequence here. You give me parser of A. Like, I wonder if I did this. What's going on? A string to A string. Value. What is contents of? Is that my instant flat map? Let's do a little more Swift documentation. Swift array contents of. Add arrays to arrays. Elements of one array to the other. Think that's okay. That's a range, but I think that's what we're doing. As the elements of a sequence or collection to the end of this one. That seems okay. All right, now I think this is going to break some other places, so we're going to have to, yeah. Cannot convert to type AST. So, okay, this is maybe helping. Let's input. Now input is just an array of characters. I think we can just use it. Cannot convert array of character to AST to expected argument array of character. So the sequence. Let's take these out for a moment. Do a build. Unexpected separator. That's really bad if not allowing that. Okay. Succeeded. Okay, let's see if our tests work. So we switched hats. We're doing some refactoring first here. All right. Digit sequence. Okay, now we're back to this digit only being here. We'll get there. We're saying everybody expects an input or expects to produce arrays. Okay. But if I get somebody who wants to produce an array of an array, I don't know what's going to happen. Okay, well, sometimes the type system helps. I guess it's what it's doing here. Let's move these up. again. Oops. Okay. Cool. Let's see. Where we left off. Well, we're going to see if that all goes. Okay, so now let's rebuild our tests. Where's... Okay, this one can go. All right, so I'm gonna say switch so that sequence returns a flat map of its input parsers. Again, I don't think we should have to do all this, but seems to be what's required. All right. So this stuff, well, okay, I guess we're setting up, we're trying to get our types right in our parser side. So this test, this constant is actually kind of indirectly, it's testing that. We're going to put some real tests in too, though. Okay, so that builds. That's good. Now let's see what optional does. I think we're going to have to do a similar move, but it'll be a good thing. All right. Cannot pass the value of array of character to expected type parser of character. Now sequence, I would have thought sequence, let's just build. I would have thought sequence built an array of parser of array of character at this point. Is that not what's going on? Cannot convert value of parser character. Okay, now if we said match such that is digit character, I'm making up one, it's not meaningful. If I did that as my body of my optional, expected declaration. Oh, a little too much grabbing there. Expected comma separator. So it, I guess optional, oh, what's optional taking? Well, sequence is a parser. Let's see if we can get this right. Parser. Okay. Sequence takes in parsers of single characters. No. Sequence takes in parsers of arrays and produces a parser array. I guess I'm saying this thing should take a parser of arrays and produce a parser of arrays. Okay. Parser test. Oh, we want Elm parser. Okay, so this now is taking that. Let's see if this can come off. Okay, please build. Okay. Whew. That's right. Now we're ready to write some tests. Okay. But I think let's see. Where should we start? I guess we'll start with the match. Well, where are our tests now? I think we are passing. I don't think we put this test in yet. No. float test fails now. Found a nil, unwrapping an optional. Parser.parse 42.1 fails. Oh, golly. Well, as he should, because optional. Let's hide this a moment. Run the tests. I think I can trust you to do that every time. Yeah. Unexpected call. I'm putting us back before our unit test, I think, but with the new structure we have of things returning things. Okay, so let's refactor a little. I'm hoping I can get rid of such that. Because I'm pretty sure it should be able to tell when it's got a predicate or a string. Okay. Should be a bunch of complaints about labels, yeah. Don't need that. That. And that. And now I should get the same thing in tests. All right. Eliminate such that from matches parameter list. One slight move for readability, I guess. Okay. Match prefix of string. Let's define some tests for that. Where's our parser tests? So we want to do match of string, and it gets a parser. Okay. Test match for empty string. Let's start at 0, 1, many. I think this may be the optional thing I'm looking for. Match for empty string. Okay, so let parser equals match of empty string do you have nothing at the front of a string? Yes, we always do. We expect nothing to be the character. I guess I expect an empty array to be the result. And I expect XYZ to still be there as the rest. Okay, and I'll highlight the sections a little bit. Okay, so test match for empty string. I don't know. Well, we just have junk in there now. I don't know. Is it match digit or something? So unexpectedly found nil. So this thing failed. Yes, because our parser, our match is junk. Okay, so we well, I'll comment this out too, and we'll just go from scratch. Okay, so we return, it's a parser that takes an input in this. Okay. Cannot convert value. Yeah, that's fine. We want to guard input dot starts with prefix, else return nil. I guess that's not even justified, is it? I can just return, let's just do a hard-coded return. I'm going to return the array, an empty array, and the input. Okay, so I'm gonna truly go down a gear and drive it right from the 0. I think this should pass. Okay, and now let's take the non-empty case. Test match for non-empty string. Wow. Okay. Let's do something very similar. Let's do XY. Array rest parse XYZ. That's fine. We want to get Z, and we want X, Y coming back as the array. Okay, so match XY. Look for the string XY at the front. If you get it, turn it into the array of stuff. If not, okay. This should fail. Okay. Let's return. I guess what I want to return is if I find it, the prefix, right? Prefix dot, oh, what's this thing called? Character view? Is that the one? View? Character array. Well, that's an old answer. Characters equals array of string. Oh, well, that's pretty good. As of Swift Force, which is again a collection of characters. Array of string. I thought there was some other thing you had to do here for that. Characters. Okay, well, I guess we'll take it. Swift 4, nobody talks about Swift 5. You don't have to use characters to use map, just do map. No, I don't need to do map. Okay, arrays of array of string is all you got to do. Okay. I mean, it's nice, but it's not what I expected. Array of prefix input dot. Oh, what do you do for substrings nowadays? Huh. Yeah, substrings. Oh dear. Yeah, substrings aren't a great way to go here. All right, but I see it's. Sorry. Hey, let's see. Missed your chat. Sorry. An Elm interpreter in Swift, working on floating point numbers. Okay, well, I think I'm back together here. They paused me halfway through trying to. I don't know. They wanted me to re-authenticate or something, some such. Okay, and we're gonna. All right. So we left off. We're just trying to get this substring out of this thing. So we want input sub. I think we use a range. So I guess if it was 0 dot dot dot, it would be everything. We want the string length, I guess. Prefix dot length count dot dot dot. Okay. Cannot substring, use a string index range instead. Okay. Swift string substring. Oh, I saw a range in there. Okay, I guess this is probably index. Dot 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 end of sentence. Greeting sub dot 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 index. That's the front. Yeah, was deprecated. Boy. Place of substring use suffix. Okay. Input dot suffix from prefix dot count. Is that going to do it? Well, oh dear. Cannot convert element of string dot element string subsequence. Okay, that. I don't know which one it's complaining about. Let's try that. Are you complaining? Cannot convert string subsequence. Okay. Oh. Prefix dot count. String range of. Oof. It's clear they had something that was relatively straightforward, but has gotten crazy. Okay, so swing suffix string. Oh, how about Swift? Suffix max length. Suffix from index. I have to get an index? Oh, I can give it a range. I guess I can do that. From, was that subscript just suffix int? Number of elements to return. Ugh, that's backwards from what I want. Okay, guys. Suffix 2 gives you 4, 5. Subscript gives you substring. Well, maybe that's the way we can go for now. Subscript. Input.subscript from a range, which is prefix.count ... And then this was array of input, array of prefix. Value of type string has no method. Subscript. We need to use the subscript. Use a string.index range instead. Oh boy. This is, I think, why somewhere along the way I read we want to do the characters and not the strings, because strings keep the characters even with their overlapping multi-byte Unicode stuff, and character view just peels off those individual characters. It will make things better for us. So it's on my list. Golly. This is what I want. Why is it not working according to documentation? Okay, streets. Well, okay. Yeah, array. Let's try this. Array of input. All right, we'll take our input array and we're going to do a substring. What does split do? Separator, nope. Arrays of input. Let's try this. Prefix.count ... and turn it back into a big old string if it doesn't like that. Recognizing this is kind of horrible. Okay, is that gonna build? So I'm converting it back from Unicode string into a array of characters, peeling off some stuff, and then turning that array of characters back into a string so I can pass it along. You can see why this would be problematic. All right, but our test should pass at this point, we hope. Okay, I'm going to delete this junk because it's the dummy stuff we had. Okay, this is progress, believe it or not. All right, so match for a non-empty string, and then let's test for a mismatch. Match with mismatched string returns nil. Returns nil. Okay, and that's a func. Okay, we're going to do something similar. Okay, we're going to attempt to match XY in X, Z, Y. Or let's just do X. Let's even just do X. That'll be a challenge. Okay, so we try for XY. We've only got X. We should get back nil. Well, this whole thing should be a nil. Result. Okay, and this test should fail. It should blow up, I think. Because our ... now is grabbing out of, too short of a thing. Okay, let's stop that test. Now we can do our input guard. If the input starts with prefix, if it does not start with prefix, return nil. All right. Run all tests. Get moving here. Oh, getting these types straight. Oh no. Unexpectedly found nil while unwrapping an optional value. Oh, yeah. Nice. Okay, so now our match operator works. Matching strings. Okay, and it doesn't blow up on the consuming them. Okay. And we want to do optional. Oh, optional's harder. Okay. So let's test optional. Optional. What do we decide on the types? I think it's returning an array, right? It takes an array, returns an array. Sorry, it takes a one. It takes a parser of returning arrays of stuff, and it returns a parser returning array of stuff. Okay. So if it's there, finds match that is there. Okay, so we're going to get a parser is match, and we'll just use our match we just did. If we're looking for X, let's look for X. Okay. And then we're going to get the result is parser.parse of, and if we find XYZ, we look for X, we should find it. Well, let's do it this way. I'll say value, or I guess it's an array, and rest. Okay, our array should be equal to X character. That's array, and our rest should be YZ. Rest. Okay. And yes, force this. Okay. Should fail. Oh no. What's going on? Oh, I didn't make him optional. Okay. Optional match X. This is why we run our tests. See them fail. Still happy. What did we do for our test? Oh, right now we just call parser. Okay, that's kind of a dummy result, but it's accurate. Let's modify this a little bit. Let's return a parser with input in something, and let's return parser.parse of input. Okay, it's kind of the same thing, but we're kind of refactoring. Okay, and then I think maybe our next test will reveal that's inadequate. Returns empty array if match isn't there. Okay, we're matching X, but we don't see an X. It starts with a Y. We should get back an empty array. This may be ambiguous, and it should be YX. Well, no, this should be a result. Oh no, it should be allowed. Yeah, it should be allowed, and we should get YXZ back. So if you don't match it, you try and match it. If it's not there, then you just return an empty array, and you don't parse anything. You don't match anything. Okay, this one should fail. Right. Yeah, because our parser, we just basically called parser match X. Match X says I must have an X. Okay. Let's see. So now we're gonna do the parser.parse. Let's let result equal parser.parse of input. Okay. If result is nil, then we're going to return an empty array, which I may have to give it a type, and input. So if you don't have anything, we return that. Otherwise, we're going to return the result you got. Okay, which presumably which we know is not nil, and will peel off accordingly, I believe. Now, I don't know. I'm surprised it didn't make me put a type on this, but maybe this does match type of parse of array of A, whatever A is. So, did I run? I don't know what my fingers did there. Let's stop that. Run it again. Build succeeded. Good. All right. So now we have our optional. Let's go back to our parser. our Elm parser, and let's see if this works. Okay. Extraneous label, yeah, we changed that. Expect a separator. Okay, so I'm going to uncomment this. (25 4215 E2). And that. I'll even say etc. here. Well, let's get it passing and then we can tweak the test. Okay, let's run this. I think we're close, if not there. Yay. Okay. And then this, I should be able to say anything after that. As long as it had something, it's probably going to be okay. Okay. Nice. All right. I was worried we wouldn't finish floating points, but I think we just did. Okay. So at least the parsing of them. Okay. So we've got this thing. Array of characters turns into an AST. All right. Now let's look at our interpreter, and there must be some tests there. Interpreter. No interpreter tests. Where's the test for integer then? Yeah. Let's pull this out into its own class. Okay. Interpreter tests. In Whelm tests, yes. Okay. We don't need any of this. Testable import Whelm. It would be nice if it put that in there for me. And we're going to pull this test over from integer test. Okay, let's run them, let it sync up. Okay. Yeah, okay, so we support parsing of floating points with digits.digits digits. Okay. So I'm realizing we're not as done as I want to be. Okay. But I think that interpreter test is good. Let's get over to the next test. All right. So, I'm kind of starting to wish my tests were simpler. I want to parameterize them basically. All right, let's get them in and we'll clean it up tomorrow. Parse digits.digits. E plus digits. I don't know how that. Okay. And I'm copying this whole test. Let's pull this out. Func check float. Okay, we take a parse literal. We want to take the value to parse. Let's take the input of type string and the expected of type double. Okay, and I think I can say, let's do input plus etc. And this is our expected. Okay, so this test should really be the same as check float 4215.15 E2, and the value is 4215.0. Okay. Just to make sure. Not that I've ever been burnt before, but there we go. Okay, this one is check float. Now you can see we're going to be making the test a little worse in that it's not going to test as many variations. Okay, because this one, the old test does an X and we did a blank and all that stuff. But I think this is going to be more readable, and I think at some point we'll just fold these together. Okay, and this one then is check float let's see, 3.1 let's see, 95 E. Well, let's make this one a capital, and we'll make this one a lower E. No, I can't do that because the process is going to be worse than that. Let's see, E plus, I can make this capital then, E plus 1. All right, and if you do E plus 1, you should get 39.5 should be our float. Okay, and I expect this test to fail, and if it does, we'll stop here. Actually, we will anyway because we're out of time. Yeah. Okay. It looks like it stopped parsing before the E. Okay. And the way the Xcode test runner sort of pulls back and we see the errors that happened in the subroutine. So that's pretty nice. All right. Yeah, let's call it a wrap for today. So we'll pick up tomorrow. We'll finish E plus or minus digits. And with that, floating will be done. We'll add the interpreter for float, which will be very straightforward. It's going to be just like the integer one. It's gonna parse a floating point number and expect to see it back with type float. That's all. So thanks for joining me. Hope you can catch me again sometime. Tomorrow is 9 to 11:30 a.m. Eastern Time. See you then. Bye-bye.